So let's think a little bit about what happens, and the next unit that we're going to look at, or the next effect on solubility, is something called complex ion formation. And typically, these complex ions will involve either a transition metal, which is in the middle block of the periodic table, or one of the main group metals over here on the right, such as, there's some lead cases that we have these complex ions. So what is a complex ion formation? And sometimes when we refer to this complex ion formation, we also refer to them as coordination compounds. And we're going to study these in great detail in the next unit when we look at transition metal chemistry. But here's a kind of a broad statement that we can say about complex ion formation and coordination compounds. So in addition to being more soluble in acidic solution, the solubility of some slightly soluble salts can be increased through formation of a complex ion. So typically, after I say this statement, students have a couple questions. Number one is, what the heck is this complex ion? So a complex ion contains a central metal cation surrounded by a number of ligands. And the thing that sucks about this definition is that I'm using a term ligand that we probably have to define to understand this. A ligand is simply a surrounding atom or ion. And these ligands act as a Lewis base, which have a pair of electrons that form what we call a coordinate covalent bond. So we'll discuss those in great detail in the next unit, but the common ligands that we will see are Cl-, NH3, H2O, SCN-, OH-, and many others. Okay? I could probably list about a couple hundred ligands. Okay, we're not going to list them all, but here are the common ones. Some examples of complex ions are Cu NH342+. That's one of them. We have Ni H2O6 2+. We could have Al OH4-. And there are tons of examples of complex ions. This is typically what they look like. You have a transition metal center, and you have a number of ligands. There could be 4, there could be 6, there's 4 in this case. We can surround these transition metals with anywhere from 2 to 6 ligands. So the next question that you typically get is, how do I know when these complex ions will form? And how do I know how many ligands are going to surround the central transition metal ion? So all the information we need to know to solve calculations based on solubility can be found in the KF tables. So for solubility, if we wanted to determine if a precipitate forms, we look at the KSP tables, which are solubility product constant, which allows us to analyze solubility equilibria. When we talk about complex ions, we look at KF tables. A KF is called a formation constant. And it's going to tell you if a complex ion will form when you put a metal cation in solution and surround it by various ligands. You will see this KF table in your qualitative analysis lab. And this is, when we're looking at solubility in the grand scheme and as a big picture, this should be the first place that you look at to analyze if a particular slightly soluble salt is going to dissolve more, or maybe it would dissolve less. So on your exam, you should rip off the solubility, or the KF table and the KSP table right when you get that exam, and make sure you have that probably right next to you. I know we'll probably be in a building where the desks are about this big to take your exam. So maybe use the desk beside you, the chair beside you. Make sure that you rip off those KSP and KF tables, because you need to be looking at them, because there's a lot of valuable information that could be contained in those tables. And when I go through the examples here, I will illustrate kind of what's going on.